Day 5. There we go. So, well, you guys haven't even started yet, so I can't really ask for your input yet. Hopefully, by day 5, you get on the groove. For the school dance, there are only 3 members from the student. For the school dance, only 3 members from the student government sold tickets. James sold 10 more tickets than Bonnie, and Bonnie sold twice as many tickets as Mike. So let's write that down. James, he sold 10 more than Bonnie. Bonnie sold twice as many as Mike, 2 times as Mike. And Mike sold X. Let's just call Mike sold Mike. So what we can do here is, you know what, I'd rather use X. So Mike sold X tickets. So if Mike sold X tickets, it means Bonnie sold twice as much as him, right? So instead of 2M, I'm going to write 2X. So she sold 2X. And then one more thing we can do is that here, where it says James sold 10 more tickets than Bonnie, well, we know how many tickets Bonnie sold, right? So Bonnie can be represented, instead of writing B, Bonnie is 2X. So we have X, 2X, and 10 plus 2X. Write an algebraic expression to represent how many tickets all 3 members sold. Now I can add them. X, which is Mike's, plus Bonnie, which sold twice as Mike, so it's 2X. And then plus James, who sold 10 more than whatever Bonnie sold, and Bonnie is represented by 2X. So we have this little expression. I can combine like terms. 2x plus x plus 2x is 3x. I can combine this guy, and this guy. Oops. So I get 5x plus 10. So the expression that represents how many tickets were sold is 5x plus 10. A total of 295 tickets were sold. So using the information above, we can now calculate how many each of the persons sold. So 5x plus 10 equals, all these tickets that were sold equals actually a value of 295. Minus 10, cross it out. 5x equals 285 divided by 5 divided by 5, and x equals, I have no idea, 285 divided by 5 equals 57. So x equals 57. So that means that Mike, which is x, he sold 57 tickets. Bonnie sold twice 57, which is 104. And James over here sold 104 plus 10, which equals 114. And just to double check, if you want to add these 3 values, you should get 295. 114 plus 104 plus 57. No, there's something wrong. Well, let's add it. 114 plus 104 plus 57 equals 275. Did I press the wrong button? 285 divided by 5 equals 57. Hang on. Oh, that's because 57 plus 57 is 114. And this should be 124. Now everything should work. So it's 124 actually, 114, and 57. Okay. Some party, So since party decorations and refreshments for the dance were donated, 100% of all ticket sales from the dance are considered profit. 295 students attended at the dance ticket. 295 students attended the dance at a ticket cost $6. How much money does student government make from the dance? Really? So it's just 295 times 6. Unless I'm missing something, so they actually made 1,770. Right? Because 295 tickets times $6 per ticket gives you this much. So we have identify each expression as either equal to 12x plus 36y or not equal. So is A equal to this or not equal to this? Is B equal to this or not equal to that? And so forth. So let's start with A. So A is, I'll find some room here. So let's take a look at A. So A equals 10x plus 36. 10x plus 36y, right? Remember, there's a little 1 over here, right? So if I use the distributive property, I can remove those parentheses. Plus, and again, there's another little 1. 1 times 2x is just 2x, and 1 plus y is just 2y. So plus 2x plus y. So if I combine like terms, 10x plus 2x is 12x. 36y plus y, remember there's a 1 over here, that's 37y. So A is not equivalent. B, distributive property, so I get 12x plus 15y, right? This times this and this times that, plus 21y. 12x, 15y plus 21y is 36y, so that is equal, so B goes in this column. C, 6 times 3x is 18x, and right away you don't have to do anything else because C is going to be over here. It's not equal to 12x plus 36y. And D, 5x plus x is 6x. 6x plus 6x is 12x. 5y plus 6 plus y equals 6y, and 6y plus 6y is 12y. And that also is not equal. So A, C, D are not equivalent, but B is. Okay. Two expressions are shown below. Apply the distributive property to write an expression that's equivalent to P. Well, so if I do the distributive property, I get 6x minus 18. Explain whether or not P and Q are equivalent for any value of x. Well, obviously not, because this is 6x minus 9 and 6x minus 18. So they're basically saying if you set x equals 1, well, this would be 6 times x, which is 6 minus 9, and that gives you negative 3. And if you substitute 1 over here, you get 6 times 1, which is 6 minus 18, and you get negative 12. So they're obviously different. So it doesn't matter what value of x you would put in, their answers would be different. Mr. Olokande is 10 inches taller than his son. Let x represent the height of him. So Mr. Olo is x, right? Write an expression in your answer to represent the height of his son. So if that is Mr. Olokande's height, the son, who is shorter, right, because Mr. Olokande is 10 inches taller, that means his son is shorter. So his son is going to be whatever Mr. Olokande is, which is x minus 10. So that's the height of the son. And if Mr. Olokande is 73 inches tall, well, now we know that x equals 73. What is the height of his son? Well, let's just replace it, and you get that the sun is 63 inches. Okay. Número 5. Joe has a sale that pays him $3,000 per month, and he also earns commission. So he's going to make $3,000 guaranteed, plus we want to write an expression that represents how much he earns per month, plus 10% or 0.10, right? Times however he sells, right? Because he gets commission. So times D, which represents the sale. So 1 month he sold 34,000 worth of items. How much did he take home? Well, it's 3,000 plus 0.10 times, and he had 34,000 worth of sales. So he going to take $3,000 guaranteed plus 10% of 34,000, which is 3,400, plus 3,400. So if you add those up, he took home $6,400. Which statement explains the identity property of multiplication? The identity property of multiplication states that number times 1 equals that number. Not this, not this, not this. There we go. 9 times 1, and the product is 9, right? And number times 1, any number times 1 equals that number. Which property is illustrated here? Well, obviously, you can tell that is the distributive property. Mary wrote a sequence using the following steps. So she started with negative 10. So the first number was negative 10. and everything after that was 4 less. So 4 less than negative 10 is negative 14. 4 less than negative 14 is negative 18, right? And then negative 22, and then negative 26. Is there something that looks like this? Yes, there is, right here. So again, let me draw a number line. So this is 0. She's starting at negative 10. To be less, it means we're going this way, because if we were going that way, we'd be increasing in value, right? Because numbers going to the right gets bigger, and number going to the left gets smaller. So negative 10, negative 14 got smaller, negative 18 got even smaller, negative 22, negative 26, negative 30, etc. So we're going that direction. 10. Which property does this illustrate? Well, again, why would I give you something the same? And I did. It's a distributive property. 10. Which of the following is not equivalent to this? Ooh. So let's do the distributive property and see if we can, rewrite this in a better way. So 4x, let's do distributive property. So it's 4 times x, which is 4x, 4 times 5, which is 20. And then if I do the distributive property here again, remember it's negative 3. So negative 3 times x is negative 3x. And negative 3 times 2 is, positive 2 is negative 6 equals 14. Is there anything that looks like this? 4x plus 20, 4x plus 20 here, 4x plus 20 here, minus 3x minus 6, and right here. Better. This one looks easy. Which of the following is equivalent to the expression below? So, negative times a positive is a negative. So this is garbage, because it starts with positive. So I want these two. Negative, what's half of 6? Negative half of 6 is negative 3. And then a negative times a negative should be a positive. So you're looking at this one. You don't even need to do the calculations in this one. You just needed to know the rules with signs. M is 12. She writes an equation to find her mother's age. M minus 12 equals 35. Which operation solves the equation for M? So if you were to do this, what would you do first? Well, the first thing I would do is plus 12, plus 12. That's it. This would cancel out, and M equals 47. So you would add 12 to both sides. The distributive property is used to simplify the expression below. Which one is the result? Well, let's do it. So it's 2 times Wx plus 2, and again, it's 2W times x, and then 2W times y, so you're going to get 2WY minus 3z. Can I combine any like terms? No, because they're all different. So is there anything that looks like this? 2WX plus 2WY? Yes, there is right here. Look at the equation below. Which inverse operations will solve the equation? So remember when we did that little story? What's my variable is n. What's my coefficient? 2. What's happening to it? Plus 1.4. That equals 8.6. So if we use our inverse operation, the first thing we should do is minus 1.4. I forgot the times here. And divide it by 2. So is there anything that says we should subtract? Right, because we're just going to subtract 1.4 from each side and then divide by 2 on each side. So subtract, then divide. There you go. Spiral 5 looks too easy. 13. Tony needs to solve the equation below. What operation should Tony solve to perform the equation for t? So again, remember, and I'll actually do this, equals 6 over 20. When we have a fraction over here, okay, we just multiply by the reciprocal. Remember, it's multiplication, right? So think about this. It's 3/4 times t. What's the opposite of multiplication? Which is dividing. So we're going to divide this by 3/4 and divide this by 3/4, right? So, but isn't dividing multiplying by the reciprocal? So we're actually just cutting this step and going straight to it. So dividing by 3/4 is the same thing as multiplying this side by 4 over 3 and this side by 4 over 3. So I'm actually, well, divide both sides by 3/4, which is multiplying by 4/3, right? If this had said multiply both sides by 4/3, this would have been correct, but actually I should have read the problem. So here's my problem. We use inverse operation. Inverse operation, because this is being multiplied, we're dividing by 3/4 and dividing this by 3/4, which means multiply by 4/3. But to this, as far as the question is concerned, we're dividing both sides by 3/4. 16. Which of the following could be represented in the solving, could be the next step in solving the equation 3 parentheses plus 2x equals 3 minus, okay, so the first thing we obviously have to do is get rid of the parentheses. So this would be 3 times x, and then 3 times 2 plus 6 equals 3. And remember, there's a 1 over here. Negative 1 times x is negative x. Negative 1 times plus 1 is negative 1. So this would be the next step. Is there anything that looks like that? Well, 3x plus 6 should be on the left side. So this is garbage, this is garbage. 3x plus 6, 3 minus x minus 1. This looks exactly what I have over here. 17. Look at the equation. Finally, some type of work. So let's solve this. 5p minus 1 equals 9 plus, and I'm going to do the street property. Positive and a positive is 3p. Positive and a negative is negative 18. Can I combine any like terms? Yes, I can. This 9 and that, so I'm going to underline this, and negative 18. 9 minus 18 is negative 9, and then plus 3p. I have a variable on each side, so let's get rid of, I don't know, this 3p here. So let me put a wall there. Minus 3p, minus 3p, right? Both sides. 5p minus 3p is 2p. Bring down the minus 1 equals negative 9, because these two are going to be 0. If you like, and again, those of you who like doing that little story, what's my variable? P, what's happening to it, times 2. Minus 1 equals negative 9. Using inverse operations, the first thing we're going to do is going to do plus 1 divided by 2 and whatever. So let's do the plus 1 on this side. Again, my little ball in the middle, plus 1, plus 1. 2p comes down, these become 0. Negative 9 plus 1 is just simply negative 8. Divide both sides by 2. And p equals negative divided by positive is a negative, and 8 divided by 2 is 4. So p equals negative 4. So the value that would make this equation true is negative 4. So you can always come and substitute to check your answer, okay? Which I'm not going to do. What about this one? Okay, so hopefully, okay, so the short way would be to cross multiply, but there's a reason why we cross multiply, and I will show you now. So here is our equation. And you notice that it's a fraction on both sides, so we have to find the common denominator. The common denominator is 12. So this would be 12, and that would be 12. So 4 times 3 is 12, so I multiply the top by 3, so I get 3x. 3 times 4 is 12, so I multiply the top by 4. So I'm going to, actually, when I multiply, be careful, times 4, I'm multiplying this whole thing by 4, so I have to actually write it like that. Right? And the next thing I can do is I can actually throw these two guys out. All right? And the reason I can throw that out is because if I multiply both sides by 12, these two eventually cross, right? So as long as I do something to both sides of the equation, I can do something. So again, I'm cutting corners. These two 12s can't cross out. Now, I'm going to stop here, and I'm going to show you how that is exactly the same if I had cross multiply. So I cross multiply. What's 3 times x? 3x. I cross multiply these two. I'm actually multiplying 4 times x plus 1, which is 4x. Well, actually, I'm just going to write 4x. 4 times x, 4 times parentheses x plus 1. Isn't that exactly the same thing? So the reason we cross multiply is because we're just taking a shortcut, right? Here I'm showing that we have to find the same denominator, blah, blah, blah. And whereas cross multiplying just skips this finding common denominator step. So that's why we are cross multiplying. So now I can do this. 3x equals 4x plus 4, right? Let's get rid of one of the variables, negative 4x. Let's get rid of that guy. Negative 4x on this side. These two cross out, and I have plus 4, or equals 4. 3x minus 4x is negative 1x, right? Now, my variable can't be negative here, so I'm going to divide this by negative 1, and I divide this by negative 1. Negative 1 divided by negative 1 is just going to be 1, or just x. And 4 divided by negative 4 is negative 4. So my final answer is negative 4. Okay, so we have one more problem. 1/3 x plus 2 equals 2/3 x plus 4. So, oh, there's a parenthesis here. Now, I am going to do the distributive property, so I get 1/3 times x, I get, right, so put this over 1. 1 times x is x, 3 times 1 is 3. Plus 1/3 times 2, 1 times 2 is 2. And put a 1 there, 3 times 1 is 3. Equals 2/3 x plus 4. Now the problem is I have this denominator of 3, right? So I want to get rid of it. I don't like to do that. So the one thing you can do, you can multiply, okay, everything by 3. So I can multiply this guy by 3, I'm going to multiply this guy by 3, multiply this guy by 3, and multiply the last one by 3. As long as I'm doing the same thing to all the terms, it's okay. So look what happens when I multiply this by 3. This and this cross out, and I'm left with x. Plus, again, that 3 and this 3 crosses out, right? It simplifies to 1, and I'm left with just 2. 3, so again, 3 times 2/3 x. I'm just going to show you. These two simplify to 1, and I'm left with 2x. And the last one is just 3 times 4, which is 12. Look how much simpler life got. Let's combine like terms, not combine like this. Get rid of one of the variables because there's one on each side. I don't really care which one, so let's get rid of this guy. Actually, no. Let's get rid of the other guy because then I don't have to deal with this negative. So, minus x, let's get rid of this guy. Minus x. So these two become 0. 2 comes down. 2x minus x is just 2 minus 1, or just x, plus 12. Minus 12 on this side now, and minus 12 on that side, right? Because this becomes 0. And x equals, what's 2 minus 12 is minus 10. And it's there. Is that it for spiral 5? Yes, it is. Okay, not bad.